Drive-by download means two things, each concerning the unintended download of computer software from the Internet. Downloads which a person authorized but without understanding the consequences. E.g., downloads which install an unknown, a counterfeit executable program, ActiveX component, or Java applet, automatically. Any download that happens without a person's knowledge, often a computer virus, spyware, malware, or crimeware. Drive-by downloads may happen when visiting a website, viewing an email message, or by clicking on a deceptive pop-up window. By clicking on the window in the mistaken belief that, for example, an error report from the computer's operating system itself is being acknowledged, or a seemingly innocuous advertisement pop-up is being dismissed. In such cases, the supplier may claim that the user consented to the download, although the user was in fact unaware of having started and unwanted a malicious software download. Similarly, if a person is visiting a site with malicious content, the person may become victim to a drive-by download attack. That is, the malicious content may be able to exploit vulnerabilities in the browser or plugins to run malicious code without the user's knowledge. A drive-by install, or installation, is a similar event. It refers to installation rather than download, though sometimes the two terms are used interchangeably. Process. When creating a drive-by download, an attacker must first create their malicious content to perform the attack. With the rise in exploit packs that contain the vulnerabilities needed to carry out drive-by download attacks, the skill level needed to perform this attack has been reduced. The next step is to host the malicious content that the attacker wishes to distribute. One option is for the attacker to host the malicious content on their own server. However, because of the difficulty in directing users to a new page, it may also be hosted on a compromised legitimate website, or a legitimate website unknowingly distributing the attacker's content through a third-party service, e.g., an advertisement. When the content is loaded by the client, the attacker will analyze the fingerprint of the client in order to tailor the code to exploit vulnerabilities specific to that client. Finally, the attacker exploits the necessary vulnerabilities to launch the drive-by download attack. Generally, drive-by downloads use two strategies. The first strategy is exploiting API calls for various plugins. For example, the download and install API of the Sena ActiveX component did not properly check its parameters and allowed the downloading and execution of arbitrary files from the Internet. The second strategy involves writing shellcode to memory, and then exploiting vulnerabilities in the web browser or plugin to divert the control flow of the program to the shellcode. After the shellcode has been executed, the attacker has the ability to perform further malicious activities. This could include stealing information to send back to the attacker, but generally involves downloading and installing malware. In addition to the outlined process above, the attacker may also take measures to prevent detection throughout the attack. One method is to rely on the obfuscation of the malicious code. This can be done through the use of iframes. Another method is to encrypt the malicious code to prevent detection. Generally, the attacker encrypts the malicious code into a ciphertext, then includes the decryption method after the ciphertext. Detection. Detection of drive-by download attacks is an active area of research. Some methods of detection involve anomaly detection, which tracks for state changes on a user's computer system while the user visits a web page. This involves monitoring the user's computer system for anomalous changes when a web page is rendered. Other methods of detection include detecting when malicious code, shellcode, is written to memory by an attacker's exploit. Detection methods also include making runtime environments that allow JavaScript code to run and track its behavior while it runs. Other detection methods include examining contents of HTML pages to identify features that can be used to identify malicious web pages, and using characteristics of web servers to determine if a page is malicious. Furthermore, some antivirus tools use static signatures to match patterns of malicious scripts, although these are not very effective because of obfuscation techniques. Finally, detection can also be conducted by using low-interaction or high-interaction honey clients. See also: malvertising, page hijacking, Blade, Mac flashback, Windows metafile vulnerability.